Okay, we're going to go through, we've already talked about the top part for a rational function. This is the calc shortcut. Okay, and if you want to go back through that and highlight any of that. If you have a rational expression where you have x's in the denominator, and this only works if x is approaching positive or negative infinity. If the degree is less on top, if the degree of p of x is less than the degree of h of x, then the limit is 0. Now, this is the part that we're going to cover today. The limit is 0, and y equals 0 is what they call an end behavior asymptote. Your graph's going to approach that. If the degrees are the same, okay, then as x approaches infinity, the limit is k, where k is the ratio of the leading coefficients. Okay, so you already figured the limit, but now we're going to take it an extra step. Y equals that ratio is a horizontal end behavior asymptote, so it's going to approach that. If the degree is greater on top, okay, then we said the limit is infinity. Okay, and y equals polynomial is the end behavior asymptote. Now, the polynomial, you're going to end up with two parts. Okay, when you do synthetic division, okay, you're going to end up, find the quotient like we did last year and the remainder. Okay, and there are two end behavior asymptotes. The quotient is what happens far away. That means your graph is going to approach that quotient graph far away. Far away from what? It's far away from the x equals, okay, some value. And it will approach this one, okay, the remainder graph near. So we're going to go through some examples on that. Okay? Okay, first problem. Let's go through this together. It says find the limit of negative x over 7x plus 4 as x approaches positive or negative infinity. Okay, do it algebraically and then confirm it graphically. Okay, algebraically what you do is you look at the degrees. The degrees are the same, so what is the limit? Negative 1/7. It's the ratio of the leading coefficients. Okay, so negative 1/7. Now, we know that's the limit, and that's basically what we did for today. Now, if you go back up to this part, okay, and y equals that is an end behavior asymptote. So, y equals a negative 1/7. That is an end behavior asymptote. And just abbreviate it, it's an end behavior asymptote. So that's going to be a horizontal line, okay? The other thing that you should be able to get is by looking at this part, okay, x can't have division by 0, can't have square roots of negatives, so just set that 7x plus 4 equals 0, subtract 4, so you'd have 7x equals negative 4, divide by 7, x, if x was negative 4/7, we'd have division by 0. So x cannot be that. Okay, so that is either an open circle, okay, or it's a vertical asymptote. In this case, it's going to be a vertical asymptote. Okay. Okay, so let's go back on the graph and use different colored pencils or highlighters or pens. Okay, we know we have y equals negative 1/7. Okay, so on your calculator, clear out all the equations. Let's put in the asymptotes first. So y equals negative 1/7, and I'm going to do zoom 6 to start. Okay, and probably don't see anything. Let's do zoom 4. Okay, you can kind of see it go along the bottom. Okay, and if you need to, let's change the window even more. Let's go for our y. Let's go negative 1 to 1, scale 1. There you go. So you see it come along the bottom there. So with a different colored pen, okay, this would be like negative 1 -2, -3, and we're going to have an asymptote -1/7 that's going to be up here. And remember, the asymptotes are dashed. And the old thing about that a graph can't cross an asymptote, that's no longer true in Calc. They will cross, but then they will approach. The asymptotes are just guidelines, okay? They will approach that. Okay, then we also have an asymptote at x equals -4/7. So if I have -1, -2, -3 here, and -4/7, we're going to have another asymptote, and it's vertical. That one you can't show, but you could do x equals second function calculate value, and you'll either have an open circle or an asymptote. Okay. Okay, now you go in and graph it. Okay, and you need to put in the parentheses. The author's not going to tell you that. Okay, so put in parentheses -x parentheses divided by parentheses 7x plus 4 and graph it. Okay. Now you can see on mine, on the TI-83s and 83 pluses, they show that spike. So this spike is actually that's my vertical asymptote. Your 84s and 84 silvers probably don't show it at all. Okay, am I right? It's not showing that spike. Okay, so on this now, on your graph, you want to show that it comes down here and put an arrow. It's actually approaching that. Okay, and that it actually comes, and it comes below the axis, and actually then comes down and approaches that graph, approaches that asymptote. Okay. Main thing, you should show it approaching the graph. Don't do this and say, well, it's going to come away from the. It's getting closer and closer to that, so try to show it approaches that. Okay. So as x goes to, you should look on your graph, as x goes to positive infinity, this graph should be getting closer and closer to our asymptote, which is -1/7. Same thing, as x goes out to negative infinity, our y value should get closer and closer to that asymptote, -1/7. Okay? Any questions on number 1? It may cross it and then come back and approach it again. But we're looking at as x gets really large. There will be some where it actually crosses it, but then it approaches that. Okay?
So where it crosses it, does it have to be an open circle there, and then actually a solution to do that? I mean, that is algebra graph.
That's not necessarily a solution to it. If it crosses the x-axis, we're talking. She was asking about the asymptote. Yeah, if it crosses the asymptote. And for today's the first time you're actually going to get a parabola as an asymptote. Okay. Okay. Turn that one over. Oh, wait. We need to. This one. We need to label that. That is a vertical asymptote. Okay. The other one's an in behavior asymptote. This one was the in behavior asymptote. The other one's the vertical asymptote. Okay. Okay. Look at number 2. Okay. And hopefully I ran off the right ones where the first time I printed this, I forgot the limit symbol. You need to have that limit symbol in there. It says find the in behavior asymptotes and the vertical asymptotes for the following rational functions. Your vertical asymptotes always come from the denominator. Okay. So on this one, x can't be 3, so x equals 3 is going to be your vertical asymptote. Okay. Okay. So at x equals 3, we need a vertical asymptote. Okay. Okay, now look at the degrees. The degrees are the same. So the limit is ratio of the leading coefficients. Okay, so the limit is 2. Now we're taking it an extra step. Not only is the limit 2, but y equals 2 is an in behavior asymptote. Okay. Okay, so y equals 2 is an in behavior asymptote. So graph that also. Okay. Sketch that. So our graph should approach those asymptotes. Okay. Okay. So now put this in on the calculator. Make sure you do parentheses. Okay. So you'd have the 2x plus 4 divided by parentheses x minus 3. Okay, and then I would probably start out zoom 6, and then we may have to go to, no, that one's all right. Okay, and you could also put in the y equals 2. The y values, remember, you can put those in. So here's our horizontal asymptote. Okay, now you should see where the graph goes. Okay, we've got part of the graph up here approaching, okay, the horizontal and vertical asymptotes. Okay, and then we've got part of it approaching, it's crossing below the origin. Okay, and then approaching this asymptote. Okay, and make sure you put arrows on both ends. Okay. Okay. So as x gets really large, as x goes to positive or negative infinity, okay, it should be approaching this asymptote. Okay, and as x gets really small, as x goes to negative infinity, okay, it should be approaching this asymptote. Okay. Any questions on that one? Okay. What were you trying to get pictures of? Oh. Okay. Okay. I thought you were taking individual shots. I thought, what's he trying to get a picture of? Okay, all right. Okay. 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 Any questions on that one? Okay. Yep.
How did you graph that vertical asymptote?
Mm-hmm. What about it?
How did you graph that vertical asymptote?
It comes from the denominator.
Oh, so just x minus 3?
The vertical asymptotes will always come from the denominator. We need to label this one too. This is an in behavior asymptote. Yeah, in y sub 2 I put in y equals 2. Okay, let's go on to number 3. Now this one's different. Okay, on number 3, because the degrees are different. Okay, the first thing I would look at is the denominator. Okay, so x can't be negative 2. Okay, so at negative 2, x equals negative 2 would be an asymptote. That would be the vertical asymptote. That's the vertical one. Okay. Okay, and then this one, the degree is larger on top. Okay, go back up to the beginning notes. If the degree, we're right here, we're right on this part. If the degree is greater on top, okay, then you have to do synthetic division to find the quotient and the remainder. The quotient is the in behavior asymptote far away, and it's actually far away from the vertical asymptote, and the remainder is the in behavior asymptote near. Okay. Okay. So go back to this. You have to do synthetic division. Okay. If they leave out a term, remember you've got to put in a term. Okay. So we would have 1x cubed, negative 5x squared, negative 7x minus 1, and we're going to divide by negative 2. Remember on synthetic, you add going down, and then multiply, and add going down, and multiply, add going down, and multiply. Okay? and we end up with a negative 15 for the remainder. Okay, now if this is an x to the third, this one is an x squared. So y equals x squared minus 7x plus 7. That's the quotient. This is an in behavior asymptote, and on this one it is far away. When they say far away, the author never answers that. Far away from what? It's actually far away from this vertical. Far away from x equals negative 2. So far away from x, from that vertical line, this graph is going to approach this asymptote. And that asymptote is your first parabolic. It's a parabola. It's your first parabola asymptote. Okay? Yes. Starting on, yeah. Okay, now, the second one. Okay? The second one comes from the remainder. So y equals. Now, the remainder, normally in synthetic division, we say the remainder is r equals negative 15. But this one, you actually have to put it negative 15 divided by the divisor. So it's all over the divisor. Okay, this part is the in behavior asymptote near x equals negative 2. So your graph is going to approach that asymptote near x equals negative 2. Let's talk about this one for a minute. Anytime you have a y to the first and an x to the first, if I cross multiply these two, I'm going to have a y to the first times an x to the first equals something. Okay? That is always going to graph a hyperbola. Okay? So our two... Go back up to this. Okay, it's all this right here. Okay, if the degree is bigger on top, okay, the limit is infinity, and y equals some polynomial is the in behavior asymptote. To get those polynomials, you got to do synthetic division. The quotient is the in behavior asymptote far away. It's actually far away from the vertical asymptote. If you want to go ahead and say that, it's far away from the vertical asymptote. And this one is what happens near the vertical asymptote. Okay? Yep. So let's go back to this. Now I want you to look at the graph under a specific window. Okay? And we're going to graph those asymptotes first. Okay? Clear out any of those equations and put in the window. I want you to go negative 10 to 10. And now, and I don't care about the tick marks. So go change that x scale to 0. And then go negative 40 to 40 and scale 0. Okay? First thing I want you to do, okay, is let's graph the quotient. So let's graph the y equals x squared minus 7x plus 7. Okay? Y equals x squared minus 7x plus 7.
So we don't do anything with the original equation here?
Not yet. We want to graph the guidelines first. Okay? Okay? Now, take one colored pencil and graph that. That is an asymptote. Okay? If you want to, I'm going to do second function calculate value at x equals negative 2 just to see. Okay, there's where my, and it is oops, sorry, dash it, needs to be dashed. And it does cross it. Now, all that tells you is far away from this line, x equals negative 2, our original graph, far away, that means out here, our graph is going to approach this parabola. Okay? Okay, now you have to graph the hyperbola. Okay? So go to y sub 2 and graph negative 15 divided by, and then in parentheses, x plus 2. Okay? And you have some of you have like different things you can do here. You can, like I can change that to a dotted graph. I'm just getting my cursor over here and changing that to a dot. Okay. Gabby on hers can change it to different colors, right? Is it working? Okay. And then graph. Okay. Okay, so now choose a different colored pencil. Get a different color. Okay. And same thing, I want to do second function calculate value at x equals -2. I just want to see where my cursor is. Okay, so it's actually doing... okay. So it should look something like this. And then the other one, crossing below, and it actually comes through here. Okay. Okay. Those are our guidelines. Okay. Now do your graph. Okay. The original graph. Okay, in y sub 3, we're going to put in parentheses x cubed minus 5x squared minus 7x minus 1, and then divided by, and then parentheses x plus 2. Okay. Okay. Now, you may want to see that graph again. If you need to see it graph again, remember you need to type over something. Here's the first asymptote, second asymptote. Now, all I'm really seeing on my graph the first time through, all I'm really seeing is, oh, I need a different color. I'm seeing, it looks like the graph is coming up, and I would have to investigate this a little bit more, but it looks like it's coming up here. I would have to investigate, is it actually crossing? Okay, and then where is it going? Is it staying on the outside? Yeah. Okay, something like this. Okay, something like that. Okay, now, here's the advantage of those asymptotes. Okay? We said that this original graph, far away from this line, should approach this parabola. Okay, is it? Yeah. Is it? Yeah. On the right side it is. I'm not seeing the left side because I forced a window. Okay? So, you need to find the rest of this graph. You got to change your window, find the rest of the graph up here. Okay? I forced a window on you. The reason you do the asymptotes is this is telling you it ought to be approaching this far away. So now change your x max, change your y max, change your values. You got to find the rest of the graph. Okay. Okay. So if you adjust your window, okay. The window she got was -40, 10, and -40, 100. Okay, you finally see the rest of the graph. So for the rest of the graph, there should be a part. There should be a part like right up here. Okay, sorry, I didn't draw that part very good. Okay, so that's the reason you do the asymptotes. Those asymptotes are your guides. They're telling you, and if you look, here's, if I said far away from x equals -2, what's it approaching? It would be this yellow part, it's approaching this part of the parabola. and over here it's approaching this part of the parabola. Near x equals -2, look what it's approaching. It's approaching this near x equals -2. Okay, this graph is approaching the hyperbola. Near x equals -2, it's approaching the hyperbola. Okay? That make sense? Starting to? I would. Yeah, it's actually, it splits the graph up. It's approaching the parabola far away from x equals -2, and the green part's where it's approaching the hyperbola near x equals -2. But the whole idea of the asymptotes is to tell you it's got to be approaching that far away and near. So that's telling you this missing part up here, you got to find the rest of the graph. I purposely picked a window that you didn't see it, okay, so you'd have to experience that. Okay, let's do one more. Number 4. Okay, the degree is bigger on top. The degree of p of x is greater than the degree of h of x. Okay, so what is the limit? I don't know if I ever answered the limit. What is the limit back up here? We didn't ever answer that. This one is infinity. And if you said as x approaches, as x gets really large, what's this y value going to? Positive infinity. As x gets really, I said that wrong. As x gets really large, it's going to positive infinity. As x gets really small, it's going to positive infinity. So on both those, you could have actually said it's going to positive infinity on both those. Okay, so on this one, it's going to infinity also. Okay, and you can tell by the graph. Okay, so first, we've got a vertical asymptote. Our vertical asymptote is x equals 2. Okay, so do a graph, do a sketch. X equals 2. And dash it. Okay, you do synthetic to find both in behavior asymptotes. So on synthetic, we'd have 1. And remember, if they leave out a term on synthetic, you've got to put in a 0. And then divide by 2. X equals 2. Okay? That's our vertical asymptote. Okay? Okay, so add going down, multiply, add going down, multiply, add going down, and then multiply. Okay, so we should get a remainder of 20. Okay, now the quotient is the in behavior asymptote far away from our vertical asymptote. So if this was an x to the third, then this is an x squared. So it's 1x squared minus 8x minus 15. And you always write it with y equals. Okay, so that is our in behavior asymptote far away from x equals -2. Or x equals 2. Not the negative, it's just 2. Okay, and the remainder, this remainder, you write that y equals, and you always put the remainder over the divisor, the original divisor. So y equals 20 over x minus 2. That is an in behavior asymptote near x equals 2. Okay, so now we're going to have a parabola for an asymptote. Okay, so let's clear out those equations. Okay, let's graph y equals x squared minus 8x and then minus 15. And I'm going to go back to zoom 6 to start. Okay, I'm not seeing the whole graph, so I'm going to go change my y min. Let's see, I picked a window. Let's go -10 to 10, -40 to 40. And turn off the tick marks, make those 0, because I don't care about the tick marks right now. Okay, so you should get an asymptote It's a parabola. Use one color for that graph. Okay, and then do your hyperbola. Gosh darn it. Okay, and put in the other one. And use a different color on that one. And put in 20 divided by the quantity, put parentheses, x minus 2. Okay. In mine, you actually see that that vertical asymptote show up on this one. Okay. And it does, this actually crosses the parabola. It actually crosses a little bit there and then comes down. Okay. And then okay. Now, the graph ought to approach, it ought to approach this parabola far away from this line x equals 2. It ought to approach it out here. It ought to approach it out here, far away. Near, it ought to approach this part near. Okay? Okay, now graph your original. And if you need to turn the asymptotes off to see the graph the first time and then turn them back on, that's okay. Put in the x to the cube minus 10x squared plus x plus 50. Put that in parentheses and then divided by parentheses x minus 2. Okay. Okay. If you need to see that, you can turn the others off. Here's the original graph. Okay. Okay, so you have part of this graph coming through, and you may have to look at it, turn the others on. You have to go back and forth on these, turn them on and off just to see. Is it coming on? It's coming on the inside, isn't it? It's coming on the inside, and then coming down, and then it's actually crossing and coming on the outside, isn't it? Now look at this. Ooh, no, it's coming on the outside. It's coming on the outside all the way down. Sorry. It's coming on the outside. It's coming outside. And then it's coming, sorry, messed up that part. Okay? And put an arrow on that. Then let me look at the rest of it. Okay. Okay. So is it coming down here? Okay. And then what? Back up? Hang on. I gotta look back at the original. Yeah, it's actually coming down that, it's coming down this line and then back up. Is it on the outside or on the inside? Is it on the inside? And then like this? Okay. Now, have we found the whole graph? Okay. Are we seeing all of it? Okay. As x approaches infinity, this would be going to positive infinity. This side would be going to positive infinity. But it's approaching this as this parabola far away from x equals 2. It's approaching the parabola. Near x equals 2, that's the turquoise part. Okay, it's approaching that hyperbola. Okay. Okay. We've got the vertical asymptotes, we've got our other two asymptotes, and we've got the limit. And you can actually say, go ahead and say it's positive infinity. Okay? Okay. We've done no, you can tell by your graph. It's going up. Right? This graph is going to positive infinity, and this one's going to positive infinity. Negative infinity would be if the graph was going down. But it's the limit as x goes to positive infinity. So as x is going to positive and negative infinity, as x is going out here, yeah. Okay. If I said what was the limit as x approaches 2, then it would be, if I changed this and said x approaches 2, then that'd be going to negative infinity and positive infinity from the right side. Okay. But it says x is getting large. Okay.